Okay, so today we're going to move away from exponentials and logarithms and some other mathy things to talk about how math can model the world around us in terms of statistics. So we're going to be looking today at some introduction to statistics vocabulary and an intro to what does it mean to be biased. This is a lot of vocabulary. So what I'm going to do is I'm going to ask you to pause your video a lot to write things in, but also know that you can find these definitions online to look them up later. You can definitely use Google when you are working on your big ideas assignment today. And also there's a glossary with your online textbook. So it's in English and Spanish if that is helpful to any of you. But yeah, so it's going to be a lot of writing, but not a lot of math. Okay. So first of all, what is a population? A population is the collection of all data, such as responses, measurements, or counts that you want information about. So go ahead and pause your video for a second and write that in, and then we'll talk about it. Okay, so most clearly the population, right? If you want to think about the population of Chicago and you wanted to know information about the entire population of Chicago, maybe city proper, or maybe even the whole Chicago metro area, it's going to be really hard to collect data from every single person in that population. So instead, what we as mathematicians do is we often look at a sample, which would be a subset of a population. So you've heard the word sample before. I mean, even something is, kind of gross is like a blood sample, right? They don't take all of the blood out of you to do some sort of testing. They just take a little tiny bit and they can get a lot of information from just a sample and they can kind of extrapolate what's going on with you. So similarly, if we wanted to know what was going on in the entire city of Chicago, we could ask a subset of the people in Chicago to help us understand better what's going on. So what I have now are 4 different kind of scenarios, okay? It says work with a partner, which I know we can't do right now. Determine whether each sample is representative of the population. Explain your reasoning. So read each one of these scenarios and just decide a simple yes or no and why this is a good representation of the population, or if you say no, why this is not a good representation. So go ahead and pause your video, read these to yourselves, and think about what it means to represent a population. All right, so hopefully you said no to all of these. For the first one, the answer is going to be no, because just because you're using random digits to dial doesn't mean that those 1,500 people that you end up choosing are actually a good sample. Plus, some people might not answer their phone, right? That's a whole problem right there with how you're surveying. To determine how many text messages they post a survey on a website. Anytime you're posting a survey and you have self-selected things, think about people who are most likely to respond to certain things. Also, if you're asking about text messages and you're putting it on an online survey, does everybody have internet to be able to access that survey? How much college students spend on clothes, talking about people, oops, wrong color, people that are leaving the university. Well, not every student is in the library, so it's not a good sample because if you're not in the library, you don't have the option of taking the survey. And then quality of customer service. Again, this is something that is where people have a choice to respond. So the people that are choosing to respond probably feel either really strongly or really negatively, strongly positive or negatively. So you got to be careful about what you're asking them to do. All right, so what you might be thinking is like, well, then how in the world do we create samples that best represent an entire population? So the best way to go about doing this is to identify what are you trying to study and what population are you trying to get information about. Choose a sample that is representative of that population. Collect your data, which we'll talk more about how to do that next time. Organize and describe the data using a statistic, and then interpret the data, okay? So first thing you want to do is figure out like, who am I trying to know information about and how can I get a sample that's representative? That's what we're going to focus on today. So this is all typed out. The best way to do this is a random sample, okay? Where every member of a population has an equal chance of being selected. But this is really hard to do because of things like your survey method. Is it paper and pencil? Is it mailing back in? Is it an online survey? Is it a telephone survey? Okay, so we got to try to think about some different ways, different samplings that we can use to help us get a good representation of the population. All right, so types of samples that exist. The first one we're going to talk about is a self-selected sample. and that's where members of a population can volunteer. So go ahead and pause, write that in. Pretty straightforward, right? You've got a group of people in a room and you ask for volunteers. It's a similar thing for who's going to take your survey, who's going to participate in your sample. Systematic is where you use a rule to select members of a population. So go ahead and pause and write that down, and then we'll talk about it. Pause. Okay, so here you can see by this group, it looks like they're picking every other person is going to be chosen. Systematic is really good if you have everybody in a list, let's say, in a Google Sheet or an Excel document, and you say, I'm going to select the 9th person. So it's like every 9th person gets selected. But you have to then be careful of how did you sort those people originally? There's a lot of little things that can get in the way. But basically it's some sort of a rule or a system. That's where that word systematic comes from. A system for how to select the members that you're looking for. Stratified. Okay, so stratified is where you're going to take a population, divide it into smaller groups, then do random selection from each group. So go ahead and pause. This is a longer definition. So a good way to think about this is if your population was, let's say, high school students at Lake Forest. Well, dividing them into smaller groups that share a similar characteristic, you could have all freshmen, all sophomores, all juniors, and then you'd have another one of all seniors. Then from each group, do a random selection using that systematic thing we just talked about, because then you're guaranteed to get a few freshmen, a few sophomores, a few juniors, a few seniors. So you get a good representation of what you're trying to find. A cluster sample is similar to a stratified sample, except instead of sorting people by some characteristic that they have in common, you're just dividing them into clusters, and then you choose one of the clusters in its entirety to use as your representation. So go ahead and write this one in. So a good way to think about cluster sampling is if you were to think about you were looking for a certain town, okay? So you put together all of the towns that have 5,000 people. So those are your different clusters. Then from that group of clusters, you select a town from that randomly to be your sample, okay? So if you're trying to find something about towns of 5,000, you'd find a bunch of different towns of 5,000 and then randomly select one of those towns in their entirety and survey those people. A convenient sample is pretty straightforward. It's members of a population who are easy to reach. So if you're sitting in the lunchroom, right, and you need to talk to some freshmen, a convenient sample would be some freshmen that are sitting nearby, okay? So it's not random, it's just people that are close by or convenient to be able to ask your questions to. All right, so that was a lot of vocab. Make sure you've written down each one of those and maybe jotted down some of the little examples that I gave. What we're going to try now is I'm going to give you these 4 different scenarios. It says you want to determine whether students in your school like the new design of the school's website. Okay, so these are 4 different ways that you could sample, and I want you to identify what type of sampling did you use for each one. So go ahead and pause your video if you were trying to decide if the students in your school like the new school website, what type of sampling is used in A, B, C, and D. Pause your video and think about it. Okay, well, this first one, it says you list all of the students alphabetically and then choose every 6th student. So to me, that screams a systematic sample because you had a system in place for how you were choosing your sample. B says you mail questionnaires and use only the questionnaires that are returned. Well, people can choose whether or not to return that questionnaire. So we're going to say that this would be a self-selected sample, right? People selected to participate. They volunteered and said, hey, I'll mail this in for you. And then you used the questionnaires of all the ones that got sent back to you. You ask all of the students in your algebra class. Well, that one's going to be convenient, right? It's people around you that happen to be nearby, so it's easy and convenient to be able to ask them. You didn't have to do a lot of work to go out and find your sample. And then part D, you randomly select 2 students from each classroom. Well, so by taking all of the students in your school and breaking them into classrooms, what you've done is you've broken them down into groups. Then from those groups, you're randomly selecting 2 students. So this is what we call stratified. Sure, I'm spelling stratified correctly. Notice that this is different than a cluster. A cluster would be that you broke down classrooms and then you chose an entire classroom to talk about, okay? This is you're breaking it down into those groups, and then from those groups, you're taking a small selection. Okay, so one of the things that comes up all the time in studies is how to recognize bias. Pretty much every study in the world has some inherent bias to it. Sometimes from something called lurking variables. Sometimes it's because we don't even know our own biases when we go to write our studies and our surveys. So what's really important as a mathematician and also as just a good thinker is to recognize why something might have a bias and how to work through that. Sometimes you can work through it, sometimes you can't, and sometimes you just have to accept it and talk about it, right? Gives good reason for discussion. So a bias is an error that results in a misrepresentation of a population in order to, this should say obtain, not abstain, obtain reliable information and draw accurate conclusions about a population. It is important to select an unbiased sample, the best that you can, an unbiased sample. An unbiased sample is representative of the population that you want information about, whereas a biased sample overrepresents or underrepresents part of the population that you are trying to actually get information about. So, for instance, a sports announcer wants to know how often people in the town attend community sporting events, and so she asks people that are at a local soccer game. Well, that's a biased sample because the people you're surveying are all at a sporting event, right? So thinking about like who are you asking? Why are you asking? And do they represent your population, or are you going to get too many answers one way or the other that's going to influence your sample? The same thing will come up when we talk about biased and unbiased questioning techniques. Are you leading the person to think a certain way, or are you being completely neutral in how you ask a question so that they answer it open and honest? All right, so again, don't forget to do your big ideas assignment. There's no math involved. It's just reading and thinking. This was a lot of reading and writing. Use these notes while you do the assignment. And again, there's a glossary in your online textbook, and you could also have Google open to try to help you make sure you understand these different scenarios. All right, we'll talk more about bias in the next lesson.